Hello, members one and all of this Salivation Nation. We're bringing you an article that I found here from the Washington Compost, and but it's just from the science section. And even in the science section of the Washington Compost, you gotta kind of be wary of the information provided therein. But nonetheless, I think this can give us a little bit of information as to why gold and silver are rare. And it has to do with heat, apparently. And here you can see an image snapshot of a computer simulation of two planetary bodies colliding. Colors illustrate how the rock of the impacting body, dark gray, the center of the impact area is absorbed by the target body, and while some of the rock of the impact area is molten or vaporized. And so the article goes on to talk about how the Earth should have a lot more gold and silver than it does. These elements are strewn throughout the solar system, but they're relatively rare here. Now scientists say they think they know why, because of our planet's hellish birth. In a paper published Wednesday in the journal Nature, Oxford geologist Bernard Wood suggests our planet's missing riches evaporated when Earth was young and still molten. Gold and silver, along with other elements known as moderate volatiles, turn to gas at moderately low temperatures. When Wood melted a mock version of an early Earth in a furnace, he found that moderate volatiles were lost from the rock like steam from a cake. Boy, that must have been pretty hot, because as many of you know, here in the silver community, there is a lot of people that melt silver and gold and turn them into bars and the like, and boy, they'd have to be very, very hot to literally evaporate it. A second Nature study led by University of Bristol geochemist Remco Hin found that evaporation also explains why Earth is dominated by a heavier brand of the element magnesium than other places in the solar system. According to Hin, our planet may have lost up to 40% of its mass when these elements were vaporized and blown into space. Some 4.6 billion years ago, which I've already kind of disagreed with that number. I believe that we have a young Earth. The solar system was little more than a newborn sun surrounded by a swirling mass of gas and dust. Slowly, the material in that protoplanetary disk clumped together, forming pebbles, then rocks, then mid-sized planetesimals, then full-fledged planets. During a fiery period aptly named the Hadean, or Hadean, after the Greek god of the underworld, Hades, the molten mass of early Earth slammed into and absorbed other bodies. Slightly later, after Earth had cooled a bit, another impact may have remelted the planet and splashed some molten material into space, creating the moon. The leftovers from this violent beginning still float around the solar system, much like flour and sugar scattered around the kitchen in which the baker has failed to clean up. These leftovers fall to Earth as meteorites that scientists call chondrites, and they provide clues about the conditions in which the planets formed. Yet, when it comes to moderate volatiles, Earth's composition is weirdly different from that of the chondrites. It is though scientists found cocoa powder all over the messy kitchen, but the cake on the table is vanilla. Many have suggested that the depletion is a result of the way these elements were incorporated into Earth as it solidified. Perhaps the moderate volatiles all sank into the planet's core, where neither miners nor scientists can reach them. By Wood's calculation, the amount of missing gold alone is enough to gild Earth's entire surface in a layer almost 20 inches thick. A planet with a hidden golden core sounds wonderful, about as wonderful as a vanilla cake with a secret chocolate center, and about as complicated to engineer. Wood thought evaporation offered a simpler explanation. So he and graduate student C. Ashley Norris set out trying to bake up a model of early Earth. They heated a furnace to 1300 degrees Celsius, about 3 times as hot as a pizza oven, a quarter as hot as the surface of the sun, to replicate the scorching conditions of the Hadean. They pumped the furnace full of carbon dioxide and carbon monoxide gas, the chief components of our planet's first atmosphere. Then they stirred together the ingredients found in the protoplanetary disk, melted basaltic rock imported from Iceland, spiced with powdered versions of volatile elements like zinc oxide, poured about a half a teaspoon of the mixture into a metal cup, and stuck in the furnace. After baking, the sample was dropped into a bucket of water to quench or rapidly cool. When Wood and Norse examined the sample, they found its volatiles were gone. Our experiment shows the melting process explained the pattern of volatile depletion perfectly, Wood said. And I'll stop right there, and that reminds me of a previous video that I had done about rapid cooling, a lesson I learned the hard way when we were melting silver, and noticed that here, as you see this this GIF showing an example model showing molten earth is dropped into a vat of water for quenching, and when we poured molten silver into a bucket of cold water, it literally exploded, and it was crazy. If we would have poured it slowly, it would have maintained its composition. I lost about, I think, over an ounce in that experiment. The scientists suggested that this evaporation could have happened on the planetesimals that smashed together to form Earth, or during the collision that led to the creation of the moon. Unknown to Wood, over at the University of Bristol, Hinn was working on a very similar problem. For years, researchers have puzzled over inconsistency in the Earth's ratio of magnesium isotopes. Rocks from Earth seem to have more of a heavy magnesium isotope than the chondrites do, but perhaps this was a result of mistakes made in the lab. Hinn wanted to know for sure. Using an instrument called the mass spectrometer, which sorts materials and their component isotopes, he and his colleagues tested an array of Earth's rocks, chondritic meteorites, and space rocks from other bodies in the solar system. They found that Earth and other large bodies like Mars and the asteroid Vesta are dominated by the heavy form of magnesium. Because this element doesn't dissolve in metallic cores, the vanilla cake with a hidden chocolate center. Model could not explain where all the magnesium went. The best explanation was that the magnesium had been vaporized. Hinn concluded that either sucked back into the sun or blown into the void of space. In calculating how much magnesium, a relatively abundant element, and other elements might have evaporated, Hinn was startled to discover that the early Earth should have lost 40% of its mass through this process, disbelieving the double and triple check the math, and was always wound up with the same results. From a gut feeling, that's hard to believe, he had said, but science is based on data, not gut feelings. In the end, I asked myself the question, what scientific argument do I have not to believe? And I basically couldn't come up with one. Then, while attending the conference in the south of France, Hinn heard Wood give a talk about his experiment. Afterwards, the two chatted about the research over glasses of wine. It's always good to know that your colleagues go through the same thought process and end up with the same conclusion, he said. In an analysis for Nature, geologist Edward Young noted that evaporation is not a cure-all interpretation for oddities of our planet's composition. Earth and Mars have different silicon ratios, for example, and Wood and Hinn's findings can't explain. Nor are these studies the first to suggest evaporation as a reason for Earth's missing elements. But, Young wrote, the relative success should encourage further exploration of the potential role of collisions in determining the chemical and isotope compositions of planets. Next, he hopes to analyze the evaporation of early Earth's more difficult to detect elements like chlorine, bromine, and iodine. He's also working on a postdoctoral fellow to use the furnace to model the makeup of exoplanets, worlds that orbit the sun far beyond our own. So it could be that collision of those planets and that massive cooling caused the evaporation of those elements, and I kind of have seen that firsthand. And and my mistake in pouring molten silver very quickly into a bucket of cold water. So post your thoughts below what you think about this article. Quite interesting indeed, and that could explain why gold and silver are rare on the Earth's surface. Would like to extend a multitude of gratitude to y'all for watching and encourage you to please rate, comment, and subscribe.